And what about this side?
Cosine.
And then this one?
Cosine.
Yeah. Now, sine and cosine is really all we need for this. I've had variety of students with different levels of comfort with trig, but right triangle trig is the crucial part. If you want to bring in law of sines, law of cosines, or some of the fancy stuff that you pick up in that second semester pre-calculus course, I have no problem with that. I think there's one problem, one video I've done where there is a nice little shortcut using one of the identities. All right, 3, 4, 5 triangle pops up a whole lot. Sometimes I feel saucy and I'll do a 5, 12, 13, or sometimes I'll just randomly make up numbers. So what would be the cosine of theta?
4.
If you're stopping there, then no.
4/5.
There we go, 4/5. Adjacent divided by hypotenuse. Sine of theta?
3/5.
Tangent of theta?
3/4.
If you want to solve for theta, how do you do it?
Law of cosine.
You could do law of sines, law of cosines.
Yeah, because of the.
Actually, law of cosines would work also. That's a lot harder way of doing it. But if you enjoy the math, go for it. A lot of physics, even the further up you, no matter how far you get, you're trying to make the problem so that the math is as simple as possible. Which doesn't mean you can't make it harder, just generally not preferred. In general, how do you solve for an unknown? If I have a single unknown in an equation.
Set the known equal to 0.
Set the known equal to 0. It definitely would come up with an answer to the problem, but often not the correct answer.
Isolate the unknown.
Okay, yeah, you want to isolate it. So how would you isolate this? Because cosine and theta are sort of linked to each other. It's not like it's a plus or minus sign. How do you separate? How do you get the theta out from underneath the domineering cosine?
Take the arc cosine of
Yeah.
each
So you
side.
got to do something to get rid of that, and that's the arc cosine,
Of each side.
which I will go ahead and abbreviate as a cos. And so theta is the arc cosine of 0.8. And what is that? If someone be kind enough. It is helpful for several people to have calculators.
Roughly 37 degrees.
Give me the 3 decimal places. Obviously, we're ignoring significant figures here.
36.8698.
Is that what you said?
Yeah.
All right. What's missing?
Degree.
If I had just written 36.8698 and left it like that, what's the implication?
That it ends there. That it's that exactly.
Oh, I would say, well, it depends upon the context, so not necessarily. Find an angle of 1, what would that be? How big is an angle of 1? With hands. All right, so we got, I got 2 people sort of going like that. We got 1 going out like that. Looks like another one going small. So we got 3 small, 1 large, 1 in the middle.
Yeah, like the arrow.
You going for small?
Yeah.
Solomon? What's, an angle of 1 would be how big? So another small? Oh, you changed your mind to small?
I meant to do small with this, I didn't.
Oh, okay. So since you were the different from everyone else, Michael?
Yeah.
Why'd you go big?
With 1 radian,
I didn't write radians.
but you didn't write degrees either, and I just assumed that. I didn't remember there being a symbol for radians, and I kind of thought maybe if you left it without the degree sign, it would be assumed to be radians.
And you are right.
Oh,
It is. So if there are no units there for an angle, it is assumed radians. Radians are a non-unit unit, or a unitless unit. If I take a circle here, and some angle here, theta, I have an arc length, I have a radius, arc length we'll call S. What's the relationship between SR and theta? All right, so let's just take the full circle. If I go around the entire circle, so S is the circumference. What is the circumference of a circle formula?
3.14R, or,
Pi r squared.
Not pi r squared.
2 times pi r.
There we go, 2 pi r. So if I do the entire circle, I have S is equal to 2 pi r. I got r. And what would the angle be in radians if I go the entire circle?
2.
2 pi.
Thank you. 2 pi. So theta is 2 pi. So if theta is 2 pi and S is 2 pi r, what's the relationship between S, theta, and r? It's not a trick question.
S times r equals theta.
If I did that times that, I'm gonna get
Never
that.
mind, S divided by r.
Okay, so S divided by R is equal to theta, or S equals, make an equal sign, S equals R theta. This is the way I'll write it most of the time, but this is also correct. Like, think of it as standing room only, SRO, except it's a theta. All right, so we have this relationship here of SR and theta, but if we look at it from this point of view, which is convenient that you came up with that way, S is an arc length, R is the length from the center to the edge. So these potentially, they're both units of length. So if this is in meters and that's in meters, my theta is unitless. The meters cancel out. But we call that radians. So radians you can always stick in there because it really has no explicit meaning. And I did have a student who stuck radians at the end of all of his answers, just for fun. It's not inherently wrong. However, you typically use radians when you're trying to communicate something. If I said the angle was 1, you would not, or outside of the context, a number of students would wonder, did I leave the degree symbol off, or what? So you put in radians just to make it clear. I didn't forget units, we're talking about radians. Probably the biggest mistake I see in these early chapters is people whose calculators are in radians when I give degrees. Although there was one test where whether your calculator was in radians or degrees, you would get the same answer. Did it once. All right, questions here? Again, I am assuming that the math background, that this is more of just a quick reminder as opposed to my having to go over it. However, all right, so any questions up to here? So let's talk about the first quiz. Chapter 1 covers some stuff that I have not gone over, but I don't think I really need to, and perhaps I will find out that I'm wrong on that. So the way the quiz is going to be, it'll be a week from today. Make sure I write this down. 251. All right. In Blackboard, under coursework, chapter 1, if you scroll down a little bit, you're going to see textbook problems for chapter 1, or textbook homework problems. There's just a set of problems there. I'm going to take, and the answers are posted for those problems. I'm going to take 2 of those questions. I'm going to change the numbers and present that to you as a quiz a week from today. So next Monday, I'm going to start out with, are there any questions? And once the questions are dealt with, or probably not an issue at this point, but there are times in which I cut off the questioning at some point, but probably not going to be an issue right now. And then we do the quiz, and then we carry on with class. So quiz, week from today.
You said that you're going to sample the questions from the end of chapter 1.
From the ones that I assigned from the end of chapter 1. So in Blackboard, under coursework, chapter 1, at some point scroll down, you'll see textbook homework problems or something along those lines. It's a list of problems. You can work on them. I think the link should be in the supplemental materials where the answers are. Apparently something I've said is troubling you.
So we can basically look at all the questions before we get the quiz?
Oh yeah. I'm changing the numbers, but yes. If you like surprises, you don't need to look.
I don't.
If you know how to do it's typically 7 problems. If you know how to do those problems backwards and forwards, the quiz will be no problem at all.
Okay.
But there are a lot of quiz grades. So the impact of one grade, the system is set up so that no one grade is going to make or break it. Right. So in case you hadn't figured it out, you're not handing in these problems. All right, so let's get into some meat. All right, so let's just pretend for right now that these are city blocks. We're looking at a map, beautifully drawn map. You are here, and you want to get here. Tell me how to do it.
You go right about 3 blocks and go up 3 blocks.
About 3 blocks?
Yeah, 3 blocks.
All right, so go right 3 blocks. And then up.
Up 3 blocks. So you're going, yeah.
Now, if you're talking to someone in the streets there, So if someone's standing there in the street and you're talking to them on the phone, and you said go right 3 blocks and up 3 blocks, I'm not quite sure they know which way was right. How could we narrow this down a little bit better?
Compass directions.
Okay, so let's just do with the traditional brainwash, north is this way.
Alright, so you had east 3 blocks and north 3 blocks.
All right, so east 3 blocks, I'll just write it 3 blocks east. And
3 blocks north.
3 blocks north. So the 2 key things here, I mean, it's obviously a simplified question, but the 2 key things here are, 1, you told how far to go and you told in which direction. If ever you need to give me, if ever it is important that you're dealing with how much and in what direction, you're dealing with vectors. How many of you have dealt with vectors before?
Does it count if I'm dealing with them during the semester?
Sure. Which, count 3?
Yeah.
Okay. The notation, I think, is slightly different based upon what one of the math instructors told me a couple years ago. So I don't know if that was textbook specific or math in general. So when we want to make this even easier, because frankly, physicists and mathematicians sometimes refer to it as they're lazy in their writing, but my wife corrected and said they're efficient. We want to be efficient in our writing. We don't have to want to write out all these words here, because the more you write, the more chances are there's going to be a mistake. So what I'm going to do is I'm just going to first establish an abbreviation of unit. I'm going to say that B is equal to block. And then I need to describe the directions, except east and north. You know what, why don't we just make that way, the east direction, we'll just call it I hat, and up, J hat. So now I can take this and I can write it simply as in 3B I hat plus 3B J hat. And so we have a much simpler way of writing it. Now in terms of notation, whenever you see the hat over it, and French grammar, it has some name that I can never remember. Anyone had French? And remember the name of that thing? If you're writing out in, I guess, LibreOffice or OpenOffice and you're doing the formula editor, hat is the key word. In physics, generally pronounced I hat, J hat. Whenever you see the hat, it's a special type of vector. So vectors in general, they're constructs, mathematical constructs, with magnitude and direction. This is a specific type of vector called a unit vector. Well, if it's a vector, it's got to have a size and direction. What would be the size of a unit vector? And the direction?
East. Oh, I hat.
Oh, that, we're talking about I hat, so
East.
first off, the magnitude of I hat, let's put absolute value marks around it, that's supposed to be an I. Apparently it doesn't like Liam doing that. And, nope. They've changed. Oh, I'm still on that. All right, the magnitude of I hat is 1, and the direction of I hat in general.
East.
Not in general. In that specific problem, yes, but not in general.
Left or right?
X.
In left or right,
Yeah.
or did you say left and right?
Left or right?
Not necessarily. There's another answer.
The x-axis.
Not necessarily.
Some unit of measurement? Like miles?
And we're looking for a direction, so. I think the spirit of what you.
Positive or negative?
Pardon?
Positive or negative?
We're defining what the positive directions are. The answer is potentially not satisfying, but at the same time, mighty. The direction is what I say it is. I hat is positive that way because I said so. If you'd said I hat was that way, well, okay, that's fine. The answer would be different. Because you defined I hat differently than I did. There's no problem with that. Which is why when you're doing these problems, oftentimes you want to define I hat. And potentially J hat, depends on if it's a 1 or 2 dimensional problem. In Calc textbook, what symbol do you use for unit vectors?
Same thing, no hat though.
No hat? Okay. Yeah, don't forget the hat in physics. Do they boldface it at least?
It's like, italics.
Italics?
Yeah.
Now, if something is not in vector, what else could it be? What's a mathematical construct that has only a magnitude?
Scalar.
Indeed it is. It's the math that you've been working with since kindergarten, before kindergarten, whenever you first started doing math. So we have vectors, we have scalars.